Good morning, everybody, and welcome to this long-term storage service at CSCS introduction. You know, we will cover why a long-term storage service is needed by myself. Then Giuseppe will explain the technical structure of this service, and at the end, Stefano will demo the service. Please ask questions on the Q&A channel or wait for the end of this webinar. So, you know that the quantity of data is increasing every day, and also at CSCS we produce a lot of numbers. But the problem is not only, the issue is not only the volume of data, is that sometimes we forgot the admonition of Richard Hamming, that the purpose of computation is insight, not numbers. So we produce more and more data to help this insight, but at the end we are drawing in data but starving for information. This issue is increased by the usual scientific data life cycle. We run simulation, we run experiments, collect data, store them somewhere, then we analyze the collected data to create the beautiful charts that fill our publications. And creating a publication is a big effort, so sometimes we forget about the data. We forget or we delete this data. But this way we forget that creating data is something really costly in compute hours for running our simulation, the access time for telescope or other instrument and so on. And other data is cannot even be reproduced, like earthquake data or climate data. Also, we forget that the data we created could be reanalyzed with other, in the future, with other methods, or combined to help other scientific results, like is almost routine at CERN, in which, for example, they combine data from 3 experiments and another experiment for Fermilab to obtain a better estimation of some data. Collecting data has also archiving and making it available has also another advantage. We can sometimes do discoveries just by browsing already collected data, like happens in virtual observatories, in which the observations are not done on a telescope, but on an archive of already collected images, sometimes creating a new knowledge. And the data created, collected, could become part of some scientific data collection that could help the work of other colleagues in the future. Like, for example, the protein data bank is a well-known example. So the trend about data in science is to move from publish and forget to use, reuse, recycle the collected data. Years ago, the scientist has been called a data ecologist because it tried not to waste natural resource, try to recycle data, preserve those data for future generations. This trend has been started by scientific journal and funding agency that started requiring to make the data result from the publication of the experiment, the projects available for other scientists. Today, instead of data ecologists, we prefer to speak about data that follow the FAIR principles, in the sense that the data should be findable, accessible, interoperable, and reusable, thinking mostly about machine actionability of this data. So to make the data available for other automated analysis. So for those reasons, at CSCS, we decided to start to make available a new service called long-term storage, starting with the first two principles of the FAIR and already working on the other two. About accessible, about storage is obvious, trivial, that is an important aspect of this service. But there is another aspect that is really interesting, making the data findable. For this reason, CSCS assigned to those data a persistent identifier. By the way, CSCS in Switzerland has been assigned as by the EPIC consortium to be one provider of those persistent identifiers. What does it mean? Instead, the scientists, instead of using some form of URL, file name, or whatever, to access directly the data, use one level more of indirection, giving a handle, a small string, to a resolver that make the translation to the URL to access the interested data. An example is in the area of publication. Instead of accessing some paper using the publisher URL, we normally use the DOI, a small handle that given to a resolver, in this case DOI.org, make us able to access directly the publication in this case. And as Giuseppe will explain shortly, the same thing happens in our long-term storage, in which we will use a PID, a persistent identifier, to access the data, which is the advantage of this kind of access to the data. Well, the scientist that gives to the long-term storage service the data access them using, as I said, this persistent identifier. This means that if at CSCS we need to move this data, for example, because some form of technology or infrastructure changes, from outside, the access to the data doesn't change. Using the same PID is access the data independent from the physical location of this data. But Giuseppe will explain this in more detail. So thank you, and Giuseppe, please.
Thank you, Mario. So, sharing the presentation.
No.
No?
Non vediamo Giuseppe.
Nothing? Okay.
Yeah, no. Okay.
Again. It's okay like that?
Yep.
Okay. So thank you, Mario. And so I'm going to give some more details about the long-term storage service at CSCS. Starting from just some background, we started at the end of 2019 and provided for some early users a test service in May 2020. And now, from the beginning of this year, the service is generally available. This is the team, these 4 people, myself, Giuseppe, Andrea, Alessandro, and Stefano. We've been working in this period to the service development. First of all, non-technical information is about the pricing. Currently, the LTS service is free of charge for user lab users. So everybody which is participating to user lab is entitled to use 2 terabytes for 10 years. Additional space can be purchased. This is the price, 600 Swiss francs per terabyte. And additional details about pricing can be asked through a help desk or contacting your account manager. So as already Mario introduced, we are aiming to we want to base this service on the FAIR principles, and to start with, we have tried to provide the first 2 principles, which are findable and accessible. In terms of infrastructure, this was done thanks to 2 CSCS services, which are the PID service, the Persistent Identify service, which allows us to provide the fundability principle. And the second one is the accessible principle, which is based on our OpenStack Swift object store, which allows to keep those data for long term. We also started to cover a bit of the reusable because we are providing licensing for the data, but this is still an ongoing journey. So the main idea, or better, the initial requirements we put on the table to design the service were this one. The first of all, the service has to provide long-term retention capabilities. For us, it means 10 years, and provide also the persistent identifiers to locate data. Then there are other requirements which regard the accessibility of data and the ease of access, basically. So we decided this service should have been able to provide public access via HTTP, and for people who want to integrate the service with third-party applications, we provide the REST API interface and also a portal to have a friendly UI. Scalability is one of the main points, because scientific data can span really from terabytes to petabytes for dataset, so this was important. And also data protection is important, because we want to preserve this data for long term, so we need to be able to be resilient against hardware, software failures. So we came up with a few ideas. The first one is a bit of, we named the storage unit of the LTS service a data collection, meaning a group of files with typically when you publish something, it's not just thanks to one data file, but you have many. This data collection needs to be immutable, because you want to find your data again in a few years exactly in the same state and with the same content. So this is a second important principle. we based the LTS service on the PID service. It's, as Mario said, provided by EPIC, European consortium, and this service is able to, a single persistent identifier is able to contain and so reference many URLs, and also provide a way to specify metadata attributes to describe the data set. Another important point is that we need to preserve data, and we need to preserve the persistent identifier so that it always points to the current content of the data set and the correct objects. So once the data collection is, let's say, immutable, there is no direct access from the user to the data. If you want to change the data, you need to go through the LTS API. In addition, CSCS is hosting part of the PID service, is part of the consortium. So we provided the identifiers, and we use these CSCS provided identifiers so that we can manage them. And in case there is any change in the infrastructure, like moving data to a different storage backend, we can update the PID and guarantee the consistency between the persistent identifier and the actual data location. So these are the main ideas. This is the sketch. Is a sketch about which explains how is at high level composed the service, and how is integrated in the CSCS infrastructure at the center. Okay, we have the LTS microservices. Is not particularly complicated. There is a REST API backend plus some additional worker microservices which are responsible for interacting with the object store on one side and with the persistent identifier service on the other side. And there is also a web portal. On the left, we have the object store, which is, as I said, based on the OpenStack Swift technology. And on the right, we have services which are used to allow authentication, kicklock, and authorization, the account and resources tool, CSCS. We use a DB, a database, to keep a list of the data collection, a message broker to allow the exchange of communication, the communication between the LTS services. As I said, the PID service, and a Docker registry for the microservices image. Okay, here I will sketch a bit again at a very high level the typical workflow when you want to store a data collection in LTS. First of all, you need to during this process, the data collection will go through a series of statuses. So the first one is new, when you first define the collection. So first of all, you need to log in to LTS, providing your CSCS, the usual CSCS credentials. So with this, LTS will check your identity with the identity service, and then we'll check if you are authorized, entitled to use the service. This information is contained our account and resource tool, which then, if all is in place, LTS will give green light to the user, which will be able to start sending the first request. The first request is in case you are want to create your data collection, is sending a bunch of information about this data collection. First of all, the name, then the description of the data collection. You can specify, if you want, a list of attributes, metadata, which allows you to better describe the data collection. And then the main part is the list of data files or objects you want to store. with their checksum. When you send this information, LTS create this logical entity, like data collection, which will be in state new at the beginning. After that, the LTS service will prepare an environment in the object store to host the data and generate a list of URLs which are then returned to the user to upload the data. And still at this point is the collection is still in the new status. Once the user receives all the URLs to upload data, he can start uploading. And when the upload operation is completed, the user will have to send a commit request to the service. The commit request has the meaning to say, hello, I'm done. All the objects have been uploaded. I'm fine, I'm done. At this point, the data collection state is committed. From this point on, the user doesn't have to do much. All the rest of the workflow is automatic. It consists of, first of all, the data collection validation, meaning that the LTS service goes and look in the object store if the data are there, if they have the correct checksum. If at this point, if everything is okay, the data collection will have a state validated. And following, there will be the request from the LTS service to the PID service to get a persistent identifier. And if everything goes as expected, it receives it and it will return the final status of the collection as completed to the user, which will have all the available information, including the persistent ID. And at this point, the collection is immutable. That's all. At this point, I unshare the screen and ask Stefano to demo the web portal. Thank you.
So, good morning. Good. Can you see my screen now?
Yes.
Yes. Okay. Good. So in this part of the webinar, I'll demonstrate how the web portal can be used. This web application can be seen as an interface facilitating access to the service. And before we jump in, here are documentation and support channel in case you need help or support. These links are, of course, available also on the page itself. Good. So. The portal can be accessed at lts.cscs.ch. And like other CSCS services, authentication goes through our single sign-on. Before you can access the portal, your project needs to be enabled for LTS. And the relevant project lead and PI should open a request for this using our service desk, accessible also here. So let me zoom up a bit. Okay, in LTS, each data collection belongs to a single project, and that's why upon authentication, the list of enabled project is first displayed. By going into the project page, its details are shown together with the list of collections belonging to it. Each collection takes up space, counts against the project storage quota. And this pie chart gives an idea of how the project space is being utilized in the context of LTS. So by going into our collection page, we get a sense of how it is defined. For example, we can review general information such as the status, the name, the expiration date, user quota, license and copyright notice, who was the creator, the project that is linked to it, as well as attributes and the objects themselves. Perhaps most importantly, it also provides access to its endo, which is used to retrieve objects and details about this collection. The handle pages are available in two different versions. The first one we refer to as the landing page, which is this one. This one you could hold on, let it load. The service might be experiencing hiccup. Okay, yeah. So the first version is what we refer to as the landing page, which is provided by the LTS service itself, while the second one, which is usually referred to as the handle page, is provided externally by the handle system. Both pages require no authentication. They are publicly accessible, and they provide the same information. It's just, as you can see, different formats. So good. Let's move on now to see how a new collection can be defined. So as Giuseppe explained earlier, the publishing process has different steps. This slide reminds us during the demo how we go through the publishing. So the creation process starts with the definition of the collection itself. And so we select the project, give the collection a name. We can specify a license. These are the licenses currently available. A copyright notice is filled by default, but can be, of course, edited. And the description is also required. Next, we have to set the attributes. Like so. Attributes are going to be an integral part of the data collection. And for example, they can be queried through the handle system itself later on. Okay, next we have to specify which files are going to be included in this collection. And please notice from the slide here on the right that the definition of the collection and the upload of data are distinct steps. So in the first part here, we have to specify which files are going to be part of it. The portal provides three different ways to do so. The first, we can specify the files individually. I have a few demo files available already here. So again, we can specify files individually, or we can, in case you have many of them, you can upload a CSV file. We provide a bash script to facilitate the process. I already have it on my computer here. So let me run it. And here it is. And so let's upload the CSV file with the files definition. Okay, good. Objects are now defined, but they now need to be uploaded. And again, the portal provides different ways to proceed. The first is to upload them individually. And for these, again, as a help, pre-written commands are provided. Let's upload the first file. Alternatively, again, if you have many files, there is another pre-written command here for bulk upload, which you could as well use. Last, the third option is in case the file size is of a scale manageable by your browser, you can even upload them through the portal itself. We will see it shortly. Here I leave out one file on purpose. So when the collection is ready, that is, all the files have been uploaded, it can then be committed. So let's proceed with this. This triggers an automated process, as also explained by Giuseppe earlier, which at a high level goes through all the files, validating them, and also proceeding with the handle assignment. Multiple services are involved in this process, which makes it possible for things to fail. And should they fail, the collection will just return to an editable state, where it can be then corrected and recommitted. And here you see, example, the validation of the files failed because, of course, we didn't upload one of the files. So the service documentation, which again is available here from the menu, provides information regarding how to deal with failures. And of course, this over time will be enhanced to include new knowledge and failures and possible solutions. But also please remember, you can always reach us out for help through our service desk here. So let's fix the issue. Let's try recommitting our demo collection, and we upload the missing file. And we retry, like so. Once the collection reaches the completed status, the diagram will disappear and its handle will be ready to be used for your needs. So let's give it a few seconds for it to complete. Good. The collection is now persistent and its identifier can be used, for example, to retrieve objects through the handle system. Like this. And the files themselves can, I think they are still being processed, but they are also, yeah, available, reachable through the handle page. So good. As I was saying at the start of the demo, the web portal acts as an abstraction in front of the service, in front of a REST API. And all functionalities that we have seen through the demo are also available as REST endpoints, like I'm showing here. And these might be useful for specific use cases, but their demonstration is not in scope for today's webinar. So this concludes my part, and so thank you, and I'll yield back to Giuseppe and the other panelists.
Okay, thanks, Stefano. So I see there are already a lot of questions which has been already answered. There are a few pending. One is about the availability of the slides. We will provide the slides. Maragazzi want to say something?
Yeah, I just want to say that if there are questions from the audience, they could simply raise their hand and we unmute them and they can ask directly.
Okay, thank you. So for the questions already sent, not yet answered, there is one about the slides. So yes, they will be provided. We will communicate after the webinar where to find them. Then there is again one from Yonut, if I spell it correctly, about the schema. Mario, so already Mario gave some part of the answers to this kind of questions. It is clear this is currently an ongoing work for LTS, so we didn't finish to elaborate on that. So this is going to change and to take some more precise answer in the future. But it's a good, of course, it's an understandable question. Tiziano, will there be a script which, given a collection ID and the directory, will generate the hashes and automatically upload the files automatically? Yes, it is already there. I think Stefano already quickly shown that when you want to define a collection in the web portal, you can download the script. It's very simple. Run it. It will create a CSV file containing a list of objects with the checksums, and then you can upload the list basically as a CSV file. Renzo asking who is entitled to use the service. Basically, my understanding is maybe Pablo and Roberto want to answer this.
Yes, why not? So the initial, so this service should be accessible by anyone. We currently provide 2 terabytes on request for user lab users, but the other paying customers are welcome also to write to support the CSCS and ask for a quota.
Okay, thank you. So I could let's go to the next. Is Urs asking about performance in uploading, downloading data from the object store, because actually, LTS, behind LTS there is this object store service. So if you are familiar with object store, you already know the answer. Otherwise, this is an answer which is very, very, let's say, approximate, and you can expect hundreds of megabytes per second for a single upload or download. And this should scale very well with the number of clients and uploads operations. I don't know if this answer to your question, but this is very difficult to say in details. It really depends. It's a shared system, which anyway is quite performant. So hundreds of megabytes per second is the answer I can give you. Then is Yonut asking, how is the funding for the LTS ensured? Can you guarantee that LTS as a CSCS service will even exist in 10 years? Good question, please.
Yeah, so this is exactly the purpose of the LTS service. So this is our promise. You give us the data today, and we keep it online for 10 years. This is exactly what LTS service is about.
Okay. If there is anybody else, you can also raise the hand at the end and just speak if you want. Okay, so it seems that there are no more questions. So thank you very much to everybody, the speakers, and everybody listening to the LTS webinar. Thank you very much. Have a good day.